On the left hand side we have soft water, and on the right hand side we have hard water. Soft water is a water that forms lather with soap, and hard water is a water that does not form lather with soap. Hardness in water is due to the presence of calcium and magnesium ions. These ions react with soap, which are sodium salts of fatty acids, to form insoluble scum. Hence, soap gets wasted. On the screen, you can see calcium reacts with sodium stearate to form insoluble calcium stearate. And in the same way, magnesium also reacts. However, these minerals are essential for humans, and drinking hard water may help you get your recommended daily intake of these essential minerals. RO or reverse osmosis is a technique of purifying water in which water is forced through a semi-permeable membrane. This not only removes bacteria and viruses but also removes minerals, even the good ones along with bad ones. Nowadays, a lot of people use RO to purify water. I will be measuring the hardness present in it, as well as tap water and packaged mineral water. And you will get to know something shocking, so watch the video up to the end. In this video, I will be demonstrating how can we determine total hardness of water. So over here, I have a pinch cork burette. In the burette, I have 0.01 molar EDTA solution, which was prepared by dissolving 0.93 gram of disodium salt of EDTA in 250 ml distilled water. This is filled up to the 0 mark of burette. To standardize EDTA solution, we can use 0.1 gram of AR grade calcium carbonate dried in oven at 110 degrees Celsius, which is dissolved in minimum amount of dilute HCl, and then volume is made up to 100 ml with distilled water in a volumetric flask. Alternatively, I have used 0.385 gram of magnesium sulfate heptahydrate, also called as Epsom salt, and dissolved it in 250 ml distilled water. Thus, the solution prepared here was of 0.0062 molarity. 25 ml of this solution was measured by the pipette and transferred in the conical flask. Now we also need a buffer of pH 10, which is prepared by dissolving 6.4 gram of ammonium chloride in 57 milliliters of concentrated ammonia solution, whose specific gravity is 0.88, and diluting it to 100 ml with distilled water. 2.5 ml of this buffer was added to maintain pH at around 10. This is Eriochrome Black T solution, which is prepared by dissolving 0.5 gram of indicator in 100 ml ethanol. 2 drops of this solution are added. I will make a video on its synthesis after my monetization is enabled. On adding Eriochrome Black T, a wine red color is produced due to the presence of calcium and magnesium ions. EDTA solution is added drop-wise with constant swirling the flask until a blue color is produced. This is the end point of titration. Volume of EDTA used here is 20.1 ml. Process repeated to get 2 concordant readings. The same procedure is repeated, but this time instead of magnesium sulfate solution, sample water is used. Over here I am using RO water. The end point came very quickly. The burette reads 0.3 ml. This procedure is repeated to get 2 concordant readings. Okay, so now let's come to some explanation. EDTA is used as a complexing reagent, and it forms soluble complexes with metal ions like calcium and magnesium. End point in this titration is detected by color change of the indicator Eriochrome Black T. The stability of the complex and color change of the indicator depend upon the pH of the titrating medium. Hence, the solution to be titrated must be well buffered by ammonium hydroxide and ammonium chloride buffer solution of pH 10. At the endpoint, the concentration of metal ion decreases abruptly. A metal ion indicator forms a complex with a metal ion. Here, where H ion 2- shows indicator form at a particular pH. However, metal ion indicator complexes are usually less stable than the metal EDTA complexes. The indicator releases the metal ions at the endpoint, and this shows a color change. In this titration, in the presence of metal ions, Eriochrome Black T forms a wine red complex. At the endpoint, when the metal ions are completely complex with EDTA, the color changes to blue of the free indicator. The calcium magnesium EDTA complexes are stable at pH around 8 to 10. The pH of the solution during the titration must be maintained at 10 by NH4OH and NH4Cl buffer. Hence, calcium ions do not form a sufficiently stable complex with Eriochrome Black T. Magnesium EDTA complex is added to the titration flask if the sample either does not contain sufficient magnesium ions or does not contain at all to produce a sharp color change at the end point. You can see the reactions. From the reactions, it is clear that 1 mole of the disodium salt of EDTA reacts with 1 mole of calcium magnesium ions. The molarities are related as M1V1 upon M2V2 equals to 1 or M1V1 equals to M2V2, where M1 and M2 are the molarities of EDTA salt and metal ion solution respectively. V1 and V2 are their volumes respectively. Now let's come to calculations. First, we calculate the molarity of EDTA solution by using standard 0.0062 magnesium sulfate solution by the formula M1 equals to M2V2 upon V1, where M1 equals to molarity of EDTA, M2 equals to molarity of MgSO4, V1 equals to volume of EDTA used, and V2 is the volume of MgSO4. On putting the values, we get M1 equals to 0.00771 molar. Thus, the molarity of EDTA comes out to be 0.00771 molar. Now we calculate the molarity of sample water by the formula M2 equals to M1V1 upon V2, where M1 is the molarity of EDTA, V1 is the volume of EDTA, M2 is the molarity of the sample, and V2 is the volume of sample. For RO water, reading was 0.3 ml. So on substituting the values, we get M2 equals to 0.00009252. Hardness is expressed in milligrams of calcium carbonate per liter of solution. Therefore, hardness in mg per liter or parts per million is given by hardness equals to molarity into molar mass of calcium carbonate into 1000. On putting the values, hardness comes out to be 9.252 mg per liter or parts per million, which is too low for consumption. There is not any limit for hardness, but 150 to 250 ppm is recommended. I also measured the hardness of Bisleri mineral water, which came to about 28 ppm, and tap water, which came to about 427 ppm. So here I end this video. Thanks for watching. Please like, share, comment and subscribe to my YouTube channel. You can also support me financially through Patreon and PayPal. I have given links in description.